Okay, so we're going to talk about absolute value inequalities. You should have a handout in class. Okay? And you're going to fill it in. There are two cases at the top, but basically what I'm going to go over is it says, what does this mean? So what does this mean? Absolute value inequalities are really just compound inequalities. Okay, and then solving absolute value, I'm not going to use that absolute value inequalities. It's an old thing. Okay, so when we solve absolute value inequalities, let's do number 1. Okay, so we have the absolute value of x is greater than or equal to 4. So remember, you usually do two cases, but right here, there's only one, or actually I should say two numbers that would make that absolute value inequality true. X can be greater than or equal to 4, right? And x can be less than or equal to negative 4. Okay? So let's graph it. So to go negative 4, close circle, all the way over here. And then there's my 0, and I'm going to take 4, and I'm going to shade this way. Now this is based on, remember when we had x, absolute value of x equals 4, we said we can substitute in 4 or negative 4. Same thing, except for you just have your inequalities. And when you write your inequalities, notice what I did. I reversed my symbol. Okay? All right, so the interval notation for that would be negative infinity and negative 4. It's closed. Or 4 and infinity. Let's look at the next one. So we have the absolute value of x is less than 7. So you make two of them. X is less than 7 and x is greater than negative 7. Okay? So we're going to say 1, 2, 3, 4, 5, 6, 7. That's negative 7. 1, 3, 4, 5, 6, 7. So that's 7. So it is less than 7 and greater than negative 7. So we're talking about all these in between here. So we're going to say it goes from negative 7 to 7. Okay? Next one. Absolute value of x minus 1 is greater than 6. We're going to make two cases. X minus 1 is greater than 6. And the other case is x minus 1 is less than negative 6. Notice I'm reversing the inequality symbol, and I'm also changing the sign. Remember we made two cases before and we had an equals? Well, think about this. We're doing the negative of it. So, all right, now we're going to solve it. So x plus 1 is 1. X is greater than 7. And then we're going to plus 1 here, plus 1 here. And x is less than negative 5. So let's graph it. So 0, I'll make this 7, negative 5. So less than negative 5, greater than 7. So we have negative infinity and negative 5, or 7 and infinity. So be careful when you're making your two cases. You reverse the inequality symbol and make it negative. Okay? All right, so let's try the next one, number 4. Absolute value of x plus 2 is less than or equal to 7. Make our two cases. X plus 2 is less than or equal to 7. And the other case is x plus 2, reversing the inequality symbol because we're making that a negative. And now let's solve it. X is less than or equal to 5, minus 2, or subtract 2. X is greater than or equal to negative 9. So my inequality is, let's see, 5. See, that's 0. Hope my distances are a little bit better than this. But anyway, it's going to be greater than or equal to negative 9 and less than or equal to 5. So it's going to be between these two pieces right here. So we're going to say negative 9 and 5. Next problem. So we have the absolute value of 3x is greater than 12. Let's make our two cases. Remember, this absolute value is all by itself, so we can make two cases. So 3x is greater than 12, and now we're going to say 3x is less than negative 12. Divide by 3. X is greater than 4. Divide by 3. X is, less than negative 4. That's 0. Let's make this 4, and this is negative 4. So greater than 4 would go this way, right? And less than negative 4 would go this way. So it's kind of like an or, isn't it? So we're going to say negative infinity and negative 4, or 4 and infinity. Okay, I'm going to skip number 6 because I want you to try that one. I'll do 7 and 8, and that should give you an idea on how to do the rest. So number 7 is x plus 3 minus 1 is less than 5. Remember, we cannot make the two cases yet because the absolute value is not by itself. So we're going to add 1 first, and then we get the absolute value of x plus 3 is less than 6. Okay, this is all by itself, so we can make our two cases. Less than 6, and the other one, x plus 3, greater than negative 6. Solve. X less than 3, and then subtract 3, and x is greater than negative 9. Okay, your graph should look like, make sure I'm on the right one, 0, 1, 2, 3, that's my 3, and I'm going to say this is negative 9 way over here. Less than 3 and greater than negative 9. There you go. So I'm going to say negative 9 and 3. All right, we'll go on to number 8. And that's the last one I'm going to do, and you're going to do the rest. All right, so it says 2 times the absolute value of 2x plus 8 greater than or equal to 12. Can't make your two cases until you get the absolute value by itself. 2x plus 8 greater than or equal to 6. Make your two cases. All right, simplify, solve for x. Solve for x. Divide by 2 on both sides. X is greater than or equal to negative 1. Divide by 2. X is greater than or equal to 7. Okay, so, wait. Did I make a mistake? I divided by a negative 2. I see my mistake. So I'm dividing by 2 on both sides, and x is less than or equal to negative 7. Always check, okay? All right, so let's graph it. So I've got negative 1, and then negative 7, we're going to say is over here. So greater than or equal to negative 1, less than or equal to negative 7. So we're going to say negative infinity, negative 7. Oops. Closed, right? Or it's either this one or that one, right? And then there. Okay, so I want you to finish the rest, and then there should be a handout for practice, and I'll see you when I get back.